Okay, we're going to be solving the integral of square root of 9 minus 25x squared. The way to do this is that you have to recognize that our goal is to use 1 minus sine squared theta equals cosine squared theta. So we want to make this substitution into here. In the case where we didn't have a 25, it'd be easier to see. So you would let a sine of theta equal x. You would let it just be the square root of 9, 3. Because since you're squaring it over here, you would get this property by just factoring out the 9. But in this case, we have a 25. So how do we solve that? The way we solve it so that it nicely cancels out is instead of having a 3 here, we just need the square root of 5, the square root of 25, which is 5, and divide by that. So we have 3 over 5, because then it works out nicely. So that's what we're going to do. We're going to let x equal this. Now just take the derivative. So dx equals 3/5 cosine theta. Now make this substitution. So we have the integral of root 9 minus 25. This entire thing is going to be squared. The entire thing is going to be 3/5 sine theta all squared. And d theta equals dx. This is what we're going to do over here. So the 3/5, you could bring that out in front, cosine theta, d theta. Okay, now apply the square. Apply the square and we get what we wanted, which is that the 25 goes away and we're left with 9 sine of theta. And then we can use that nice property. 9 sine theta, because this is squared, so this becomes a 9. This is squared, this becomes 25, cancels with that. And this is squared. Cosine theta, d theta. So this entire thing, factor out the 9. Factor out the 9. It's going to become a 3, so we might as well just do that. So you factor out the 9, you're left inside with a 1 minus sine squared theta. You got the cosine theta, d theta from over there. And we had a 3, right? So 3 multiplied by that, we've got 9/5. Now, this is cosine squared theta. It's square rooted. So we're left with 9/5 integral of, if you have a squared and then you square root it, it's just cosine theta. Cosine theta times the cosine theta from over here is cosine squared theta. Cosine squared theta, d theta. So now we just have to use the half angle formula. For that, we're going to need more room. Just use the half angle formula. So whenever you have cosine squared of something, that's the same thing as saying that you have 1/2 1 plus cosine of 2 theta, d theta. That's exactly the same thing as that. We're just using a property of cosine. So you bring this out, you've got 9/10 outside, you've got the integral. Now integrate each part individually. What happens when you integrate 1? You just get theta, right? So might as well just do it. theta. What happens when you integrate this? Cosine of 2 theta. You get positive sine 2 theta over 2. Over 2. Because you've got this inside, and whenever you integrate something that has this inside, you divide by it. Plus c. So you would think, okay, we're done. And we pretty much are. But we have to remember that we didn't start with theta. We started with x's, right? And if you recall, we let x equal, let me clear this, okay? We let x equal we had a sine of theta, right? So this is a constant. How do we actually know what constant to use? The way we know which constant to use is by looking at this, and we want to make sure that we can use the property of 1 minus sine x squared. So we take the square root of whatever the constant is. In this case, we also had a 25. So it's not as easy as just letting this be 3. We have to divide by the square root of 25. So we actually let this be 3 over 5 sine theta. So how do we actually now isolate theta? How do we solve for theta? The way to do it is do some simple algebra. 5/3 x equals sine theta. Now, inverse sine on both sides solves for theta. So, sine inverse of 5/3 x equals theta. Now just plug this back into theta, and you have your answer.